Okay, guys, we're moving on to a new chapter. In this chapter, we're going to be finding lateral area, surface area, and volume of three-dimensional figures. So we got a bunch of them. We got prisms and cylinders and cones and spheres and pyramids. Today we're going to talk about prisms. So what a prism is it's a three-dimensional polygon. It has two parallel and congruent bases, and then it has things called lateral faces that will all be rectangles. All right, so first thing I'm gonna do is show you guys how to draw a prism. It's super easy. You're gonna figure out what kind of prism it is. So prisms are named by whatever the shape of the base is. So our example that we're gonna do is a right triangular prism. What that means is that the base, that we have two of them, is a right triangle. So here's how we're going to do it. We're going to draw a right triangle. So right there. And then what I want you to do is I want you to take that same exact triangle, go over and up, and do your best to draw the same size triangle again. So go up over a little bit ways, and then go up a little bit of ways. Do your best, try to draw it about the same because these are supposed to be the same exact figure. Okay, now what you're going to do is you're going to connect any corresponding point. So like this is the top and that's the top. We're going to connect them. Right there. Bottom right, connect them right there. And then this back one and this back one, I'm going to do that as a dotted line because since it's like three-dimensional, you technically shouldn't see that from this angle. That's called a right triangular prism. So, like I said, when you look at a prism, there should always be two sides that are congruent and parallel. They're known as the bases. So that's going to be the right triangle. This is a base. This is a base. Good. All the other parts, all the other faces of the entire figure, they're called lateral faces, and they're rectangles. So we got three rectangles here. We got the bottom, we got the back, and then we got this slanted rectangle. So those three rectangles together, those are all known as the lateral faces. So I'm just going to put one big one. So like this is a lateral face. Lateral face. Get rid of that little extra mark right there. Okay. Now, the line segments that connect one base to the other. So the three that we drew to actually make this figure that connect one base to the other, those are known as lateral edges. So we have lateral edges, and there's three of them. There's that one we drew. There's this one down here. And then there's this one all the way here in the front. Those are all known as lateral edges. Super important thing I'm about to say right now. Lateral edges are the height of the prism. Almost every single formula we're going to do, you're going to have to know the height of the figure. That's the height. Now, you won't always see a figure drawn sideways like this. It could be straight up and down like this. It doesn't matter if it's drawn sideways or up and down. Any line segment that connects one base to the other base will be the height of the prism, which, like I said, you will need. Okay, so what we got going on here is we're going to have three different formulas that you guys are going to need. So that formula sheet that you guys made from the last chapter on area, you're going to want to just add this stuff to it. So you're going to want to write prism and put in these new formulas. All right, first formula is going to be called lateral area. And all that is that is the area of all the lateral faces. The area of all lateral faces. So the rectangles. So like if I found the area of the front one, the back one, and the bottom one, each of those rectangles and add them up, that would give me the lateral area. I just don't want to have to do that because I have a much easier formula. So here's your formula for lateral area. LA for lateral area equals, now capitals and lower cases are important. This is a capital P, lowercase h. So what that is the P is the perimeter of the base. You can't just say perimeter. Three-dimensional shapes don't have perimeter. Two-dimensional shapes have perimeter. So we have to go to the base, which is either this triangle or this triangle, and we're going to find the perimeter, which means find all three sides and add them up. That'll give us the perimeter of our base. The H stands for what H always stands for. It stands for the height. But the problem is that's not good enough either, because which height? Are we talking about the height of the prism, or are we talking about the height of the base? Because like this right here, that would be the height of the base right there. But that's not what it is. It's the height of the prism. Height of the prism, which is the lateral edge. Okay. So there's your first formula. This needs to find its way on your note card. So that'll be your lateral area. Next one. Total surface area. Total surface area is exactly what it says. It means the area of every single face on the entire figure, which in this figure would be the three rectangles, which you just did right here, and the two bases, because there's 5 surfaces here. There's the base, this rectangle, the back rectangle, the bottom rectangle. That's what the total surface area is. So total surface area, you're looking at all faces combined. Okay, we have a formula for that too. First of all, we call it T. T for total. It's going to be, now remember, you found the lateral area already. So you've already found these 3 rectangles. So we don't have to redo those. So what we're going to do is we're going to take the lateral area, which is the answer you just found, and you're going to add in the area of these 2 bases, because that'll give you all 5 of them. Now we write that as 2 capital B. Do not put lower B. Lower B means base. Capital B does not mean that. Capital B